Welcome back to another Rockpile Tutors Homework Helper. Today we had a session with a student and I'm a little bit rusty on matrix algebra, so we had a problem I couldn't figure out on the fly, so I came home, decided to figure out, and here's what it is. What we're going to be doing is in matrix algebra, we're going to be doing 3 separate transformations of an XY pair and figuring out how to do that and how to end up with a single transformation that will get us to the end. So the big picture we're going to do is we're going to take a point in the XY plane and we're going to apply 3 transformations. The first is we're going to rotate counterclockwise pi over 6 radians. After that, we're going to reflect over the line y equals x over the square root of 3. And then finally, we'll do a clockwise rotation of pi over 3 radians. All right, how we're going to do that? We're going to figure out each transformation matrix using the definitions of how to do each type of matrix, each type of transformation. And then we're going to combine them, and we multiply those transformations in reverse order. And it's basically because it's like a composition of functions kind of thing, where you're applying each function to the output of the previous one. And so we end up going backwards. And then we'll do a check by using an example of starting from the point 3, 5, do each step, see where we end up, and then we're going to do the full transformation or the final transformation matrix in one step and make sure we get to the same place. All right, so transformation number 1, we want to rotate counterclockwise pi over 6 radians. So what we're doing is something like, right, if we start here, let's say that point here, right, from here, we're going to rotate by pi over 6 or 30 degrees. All right, the formula, generic formula for doing that is you apply the matrix cosine, negative sine, sine, and cosine for a counterclockwise rotation of theta degrees. In this case, we're going to plug in theta equals pi over 6, and we're going to end up with this transformation matrix, right? Because the cosine of pi over 6 is root 3 over 2. That goes here and here. Negative the sine is 1/2, so negative 1/2 and 1/2. We're going to talk about transformation 2. We're going to take that point and reflect it over the line y equals x over the square root of 3. So square root of 3 is about 1.7, so this is roughly a slope of 1/2. So that line is going to look, I don't know, something like that. And so a rotation will go from here across to down here somewhere. All right, and looking up the general formula for the reflection over any line y equals mx, using the m as the slope, is 1 over m squared times the matrix 1 minus m squared and m squared minus 1 on the main diagonal, and then 2m in the other two. And as we said, our slope, is 1 over the square root of 3. So applying that, we end up with, let's go with 1 over m squared is going to be 1/3, so that's going to be 4/3. And if I multiply by the reciprocal, that's going to end up being 3/4 as a scalar times, here we go, 1 minus m squared. So 1 minus 1/3. Down here, we're going to have 1/3 minus 1, right? M squared minus 1. Up here, 2 times m is 2 over the square root of 3, and similarly 2 over the square root of 3. When I multiply the 3/4 times each of these, I end up with, where are we? 1/2. Well, let's go through this. This is 2/3. 2/3 times 3/4. The 3's will cancel, and I'll have 2 over 4, which is 1 over 2. Coming up here, 3/4. The 2 and the 4 will half cancel, and I'll have 3 over 2 times the square root of 3. 2 times the square root of 3. And this is 2 square roots of 3. So we can erase that. We can just call it root 3 over 2. And then similarly, this is going to be negative. Where did that come from? Negative root 3 over 2? No. Positive root 3 over 2, again, because it's the same. And then down here, we're going to have 1/3 minus 1, which is negative 2/3, times 3/4 is negative 2/4 or negative 1/2. Give it a shot yourself, pause, and make sure that you end up with these same answers. And so this is going to be our transformation number 2, and you can see it right here as well. All right, next we're going to do transformation number 3. This is where we rotate clockwise pi over 3 radians. The formula for that is the same as counterclockwise, except the negative on the sine diagonal is in the bottom instead of the top right. So with this, and our theta now is pi over 3, where cosine is 1/2 and sine is root 3 over 2. So the cosine will be 1/2, cosine will be 1/2, sine square root 3 over 2, and negative sine negative square root 3 over 2. So those are our 3 transformations. Because the transformations are applied using the output of the previous transformation, it acts like a composite function. So if you had f of g of x, right, it's written this way, and you have to start on the inside because the output of this is what the input to f is. Don't quite have this nailed down as a good explanation, but as a result, the functions that we apply, right, if you think about in order, we're going to go from xy, we're going to do this to it, and then we're going to do this to that, and finally, the last rotation, this to the result. So you write it out like this, and you end up doing it in reverse order. So let's look at the first step we're going to do. We're going to take the final rotation, which was transformation 3, and multiply it by transformation 2. So we're going to have 1/2 root 3 over 2, negative root 3 over 2, and 1/2. That times 1/2 root 3 over 2, root 3 over 2, and negative 1/2. All right, you see where we got that? This is transformation 3. This is transformation 2. So if I do this, I'm going to make it's going to be a 1 by 2 matrix. And the first one is 1/2 times 1/2, or 1/4, plus root 3 over 2 times root 3 over 2, which is 3/4. So that's going to be 1. Similarly, you can see up here we do the same thing. So I do think you should pause, make sure that you're going to get these at least, and then come back and watch the video. So that's going to end up with these, and that resolves into a 1, 0, 0, 1, which essentially keeps the same x and flips the y, which is what that matrix will do. And we'll see graphically what that does in a bit. That's a bit of a mess for the first one here. They don't get easier, but they get a little bit simpler. So now that we've done those first two, now we apply the first transformation, or the counterclockwise by pi over 6, and this one's a lot simpler because you're just doing 1s and 0s. And so that basically keeps the top row the same and has the negative of the bottom row. And that is our final combined transformation matrix. Now, how are we going to check if we're right? So what we're going to do is we're going to take the first point, we're going to take a random point, 3, 5, and we're going to apply the transformations one at a time and see what we get for intermediates. So now I'm going to start with 3, 5. The transformation I apply is transformation 1, root 3 over 2 on the diagonal, negative up top half on the bottom. Let's make sure that I'm doing the right one. Yep, okay. And so this is going to be this term times 3 and this term times here. So the top will be 3 times root 3 over 2 minus or plus negative 1/2 times 5 or minus 5 over 2. That comes out to about 0.10. And then this one is 1/2 times 3 plus root 3 over 2 times 5. That comes out to 5.83. Now I apply the second transformation, which is the reflection over the line, and my transformation number 2, 1/2 negative 1/2, and root 3 over 2 both places here. Right, negative 1/2, root 3 over 2 times 0.1. So now I've got 0.1 over 2 plus 5.83 times root 3 over 2. And on the bottom I have 0.1 times root 3 over 2. Oops, that's a minus. Minus 5.83 times 1/2. That's going to come out to negative 2.83. So now we're moving around. We've moved up, and now we're moving down and to the right. Step 3 will be our final one, where we then go clockwise, pi over 3. So I take transformation matrix number 3, 1/2, 1/2, 3, root 3 over 2, and negative root 3 over 2. And, nope, here we go. 1/2, 1/2, root 3 over 2, negative root 3 over 2. 5.1 times 1/2 plus root 3 over 2 times negative, the math is right. This is missing an over 2. And then on the bottom we have 5.10 times negative root 3 over 2 minus 2.83 times 1/2. That comes out to 0.1 over 5.83. Now the way to check that, after doing 3 separate rotations, so we went rotate, reflect, and then rotate. Now we're going to take our one-stop shop, the final transformation matrix, and apply that to the original point. And we have root 3 over 2 times 3 minus 5 over 2 and negative 3 over 2 minus 5 root 3 over 2, and that comes out to 0.1 and negative 583. So we've shown here that doing it step at a time and doing it with our single transformation end up with the same result, which means we've done the problem correctly. And then finally, ChatGPT helped me out with a visualization of what we're doing. If we start from 3 over 5, right, and then we rotate counterclockwise, we'll get here. It's almost on the y-axis, but not quite, at 0.1. Then we're going to reflect, so here's that line. We're going to reflect over it to here. And finally, we rotate by pi over 3, or 60 degrees, and that ends up being all of that mess just for, well, it was one rotation and then a reflection over the x-axis. So I hope this made a little bit of sense. I think if you pause and try to do the matrix math yourself, you will get better at the practice, and then use the TI-84, and you can do all of this stuff pretty easily. But I think it's important to go through it once by hand at least, so that you understand what the calculator is doing, and hopefully you can find errors. So, hope you enjoyed this, hope this helps, and if anyone's looking for tutoring, come see me at rockpiletutors.com. Have a good evening.